Hey guys and girls, here's Heiko. I want to finish up a video that I started filming quite a while ago, the installation of my Silent Hektik ignition system. I've since been riding the bike with that ignition system in it, but when I was editing the installation video, I noticed that one really important piece was missing. I don't know if it got lost while I was trying to transfer files from my phone to my computer. I don't know what happened, and that piece was the most important, the actual install of the hall sensor pickup and the trigger wheel. And I also had previous videos where I showed how to make a piston stop. So I wanted to show you guys how to verify top dead center properly. But then I'm actually kind of glad that I lost this piece of video, because Tom Cutter, one of the guys on Facebook, an expert BMW expert mechanic, he has his own business. He made a couple good points, and I want to pass them along so that yeah, you potentially don't damage your motorcycle while trying to verify top dead center. So let me change camera angle, get my degree wheel, and then we're gonna just in theory talk about how to establish top dead center. Quick little side note, I am assuming, since this is a German motorcycle and I am German, and I know that most Germans are pretty anal about everything, that the markings on the flywheel that give you your timing are pretty accurate. So as long as this engine hasn't been taken apart by, you know, like a shade tree fix-it mechanic at home and installed the flywheel in the wrong location, if that is even possible, let me think about that. You can assume that your timing marks are somewhat on the money. So verifying top dead center probably is only a good idea when your engine is apart and your transmission is not connected, so that you just have the crankshaft, the pistons, and you can by hand turn your crankshaft in both directions. And maybe even when you're in the process of putting the cylinders and the heads on, you could leave the head off, bolt the cylinders down with some spacers and nuts to push them against the case, and then some people make themselves a little bracket like that goes across the cylinder opening with a little stop screw in the middle, and then do your top dead center verification. But yeah, so doing that while the engine is in more or less functional conditions with a transmission attached to it, and the only way that you can properly spin your crankshaft is by means of putting it into gear and then bumping your rear wheel, is kind of a dangerous situation. But let's proceed here. All right, guys, so I hope you have a good view. Here's your alternator, and you can see the trigger wheel of my Silent Hektik ignition is already mounted there. If you would want to do a top dead center verification, and as I already mentioned, best scenario would be if you do it when there's no transmission connected to your engine, and maybe even if there are no cylinder heads mounted yet. So you're in the process of reassembling the engine. You will be putting a new clutch on there and all that. So the rear end of your engine is all open, and you're in the process of putting the cylinders on. So the seam between the cylinder and the cylinder head is about here. If you now imagine this cylinder head is gone, and you would use, there are 6 bolts that hold the cylinder head and the cylinder on, and when the cylinder head is not installed, you only have 4 bolts that you could use to hold down your cylinders against the case. Could use some spacers and then put some nuts on there, and then make yourself a piece of flat steel going across the cylinder itself, and right in the middle of it you drill a hole, tap it, and put a bolt in there as some sort of piston stop. The idea here is that you would be able to bring the piston, doesn't matter on which side you do it, by the way, it's top dead center. Both pistons are always, it's called a boxer engine because they're always moving the same direction. So both pistons move outward and then hit top dead center. In one case it is the exhaust stroke, and in one case it's actually the compression stroke. But for the top dead center verification, it doesn't make any difference. So as you then move your crankshaft slowly and the piston move outwards, you could, right before it reaches top dead center, screw your little stop screw that's on that flat steel. Wait, Shaba, I'm making a video. Can you please not? I'm making a video, Shaba.
What can I have for the bowl?
It's almost perfect timing. Every time I make a YouTube video in the garage, someone is going to walk in here. But anyways, so that piece of flat steel with a bolt in the middle, you're moving your piston outwards close to top dead center, and then you screw your little stop screw in so that it touches the surface, the top of the piston, and stops it in its track. So it cannot go forward or closer to top dead center anymore. Now you grab the crankshaft and turn the crankshaft the other direction until the piston again comes back up towards top dead center, and will eventually again touch your little stop screw that you have mounted right in the middle of the piston. And now let's talk about how this comes all into, this is a degree wheel. This is Motion Pro. It's a little large. It would be nicer to have a smaller version to be able to mount it a little easier here on your alternator. The alternator is driven by the crankshaft. So the rotor of the alternator is bolted to the end of your crankshaft. So this is where you would want to bolt a degree wheel like this one. You take the bolt out, put that here in front. You might need a washer or whatever, and then just tighten it down. You don't have to crank it down. It just needs to be mounted so that it doesn't move by itself. So it's supposed to move with the crankshaft. And then you find another, maybe one of the bolts that holds the engine cover on. Use that bolt to hold a paper clip. Let's say paper clip. You bring your piston towards your piston stop. Make sure that you are like 5 degrees before you reach your top dead center mark here on the side of the case. And then set your little paper clip, let's say on 0. Just bend it so that you have a pointer that lines up with a 0 mark here on our degree wheel. And then, like I said, you turn the crankshaft the opposite direction by hand on your crankshaft, and eventually your piston is going to come out again and will touch the same piston stop, and it will come to a stop. Let's say your pointer is lining up with a 20 mark here. So the first stop position was 0, the opposite direction stop position is 20. And so here, let's move over to my whiteboard. I'm going to give you a kind of a rough drawing, since we can't really do it here right now, but I kind of made the commitment to myself to try to explain this a little bit. All right, guys, so little drawing here. That's your crankshaft, your connection rod, your piston, one cylinder, and this flat steel bar that I mentioned with a bolt up in there. So now you turn your crankshaft one way until this piston touches, not slams into it, but touches your piston stop and doesn't move anymore. So now imagine you have on your crankshaft, right where the alternator is, you have a degree wheel mounted, and you have made yourself a little pointer out of a paper clip, mechanics wire, zip tie, just something that stays in place. It's mounted to the case somehow, and it doesn't move when you crank the crankshaft. So then you are now at, imagine this is touching here, yeah? Now imagine you are at top dead center in this way of rotating the crankshaft, and you set your pointer at 0. So now imagine you would grab the crankshaft and then turn it the opposite direction, almost 360 degrees, until your piston top again bumps or touches your piston stop. And suddenly you notice that your pointer that you had completely left alone, you have not touched it, you just turned the crankshaft almost 360 degrees the opposite direction until the piston was stopped again, is now pointing at 20. So now you can establish that some exactly halfway between those two stop points. So stop point one direction was 0 and stop point the other direction was 20 degrees, that your actual top dead center is right in the middle between. So here in this case, really easy, it would be right at the 10-degree indication. It really doesn't matter all that much in this instance how your degree wheel is oriented or mounted. You just have to put your piston against the stop, pick one degree number that's easy to read, and line up your pointer, then turn the crankshaft the opposite direction until you run into the stop again, and then read the next degree number, and then the difference between those two is top dead center. So now what you could do is you remove or retract your piston stop bolt so that you actually can go past those two stop points. Now you turn your piston, or you move your piston until you're right in the middle at what we just established, 10 degrees, have your actual top dead center setting, and then you go back to your engine case. And while your engine is still in this newly established top dead center, you verify where your OT mark is. Like I said, BMW made in Germany, in Berlin. I'm assuming they are pretty anal about everything. So if your method was correct, establishing top dead center, you should have OT mark in here. And just to give you a quick little reference here, the way the Germans were going about those timing marks, they actually don't use the symbol like this. For example, is S for spät, which is your timing mark for when you actually adjust the timing with a running engine. They don't use the S as the mark, but the line above it. And that's the same applies with the OT mark. I wish I would have a picture of the OT mark. Here, let me try to get my engine spun so that we can see my OT mark. Here, give me a second. So now you can see my OT mark, and next to the OT is a small line. And that's the established factory top dead center mark. OT stands for oberer Todpunkt, which is German for top dead center. That little punch mark that I kind of colored, that's the top dead center that I established with my piston stop. Yeah, so verification of the factory OT. So, and now let's talk about why it's not a good idea to do this in a fully assembled state when your engine is completely assembled. Let's see if you can actually see what I'm talking about. So you can see the spark plug is kind of at a pretty steep, now let's say shallow angle towards the piston. If you now use a piston stop, how I showed in my video how to make one, it's pretty much just an old spark plug and a long bolt that goes through it, and then I rounded off the end a little bit, and it has a lock nut on it so you can lock it into position. If you put that in here, then it is a really weird angle towards the piston. And if your bike is completely assembled like this, and you actually have to turn your crankshaft by bumping your rear wheel in gear, the piston might hit this piston stop hard enough that you actually may distort the threads that are in the cylinder head. And Tom Cutter brought up that point, and I totally agree with him. This is all pretty soft cast aluminum, and you know, people over tighten stuff all the time and strip out threads, and you definitely don't want to strip out the spark plug threads, or else you have to take the cylinder head off and do a proper repair. So when this is mounted in here, you have such a weird angle towards the piston that you actually might have enough force to damage the threads of the spark plug. And then the other thing is that if you bump it with a gear, you might even put a nick into the top of your piston. So I would say I agree with Tom Cutter completely, and I would not do this again. I already did it once, got away with it, verified that the factory OT mark is pretty close to what I established and marked with my little punch mark there. So if you have a running bike and you are just adding a electronic ignition to it, and the whoever makes the ignition, doesn't matter if it's what is it, EME or Silent Hektik or Boyers or all the other brands, I can't come up with it right now. Just go with the marks that you already have on your flywheel. If you do a complete engine rebuild and you are in there anyways and you have free access to your crankshaft, why not verify the marks on your flywheel? Doesn't hurt. So yeah, just go with what you have on there. So now let's get back to the install of the Silent Hektik. You can see that this little trigger wheel here is mounted right onto the end of my alternator, onto the rotor of the alternator. It actually uses the factory bolt. And if I'm not completely mistaken, here, let me stick my head in there real quick. Yeah, it uses the factory bolt, and I think you omit the washer. So the thickness of this trigger wheel is similar to what the washer used to be. So you omit the washer and then run your original bolt back in there. Here, let me move you a little closer so you can see the details there. Let's zoom in a little bit on this whole thing. There you go. So that is pretty simple, right? These four holes here, they are made for a wrench of a angle grinder. Here, let me grab one real quick. If you guys have a shop, you probably have an angle grinder, so you have one of those wrenches, and they made them so that the wrench here fits right into the holes of this trigger wheel. So when you torque down this bolt, it is beneficial if you maybe have a helper to put a screwdriver through your timing hole and lock the crankshaft by means of the flywheel. Then you hold this trigger wheel with this, and then you can torque the bolt in the middle. And then where else that also comes in handy, they give you a kind of a static timing. See, there are 1, 2, 3, 4, 5 little knobs sticking out. And this one here, I even marked with a Sharpie. That's the one that does the static timing. So currently my engine is sitting at top dead center. And you can see that this is sitting right on top of the pickup. This is a Hall sensor pickup here. And they kind of give you a rough idea. There's a little punch mark here. And you're supposed to put this edge in line with the punch mark. And then you have a rough timing so that the engine will start up. And then you verify the timing later with a strobe light. The pickup itself sits on a little steel bracket, and that gets bolted down together with this terminal block here. That's part of the wiring of the alternator. So you take the original screws out, put the bracket in between, bolt it back down, done deal. Then they give you a certain measurement. I think it was 0.6 millimeters of a distance between the trigger wheel and the Hall sensor. So you put a feeler gauge in between. If it's not enough spacing in between, they give you shims that you put behind this trigger wheel before you put the trigger wheel on and the bolt through. So you can space it out. I think each shim is 0.1 of a millimeter. So it's really easy to get to the right distance. I mean, ultimately, I don't think it's all that critical. If you're closer or a little more away from this Hall sensor pickup, I think I'm right on the money. This install here was really simple. You know, literally this thing bolts on with 2 bolts right with this terminal block, and this uses your original alternator bolt. And you just have to set your engine at top dead center, then adjust this trigger wheel so that this little one nose here lines up with the Hall sensor marking, and then you have someone lock your flywheel with a screwdriver into the teeth of where the starter engages, and then you use your special wrench, hold this thing, and torque down the bolt. I had to manipulate it a couple times. I really wanted to get it right on the money. So this here is a 74 R90/6, and the idle timing, the idle ignition timing is 9 degrees before top dead center. Silent Hektik wants you to put it at 6 degrees before top dead center. And of course, we don't have a 6 degree before top dead center marking on the flywheel. I do have a timing light that allows me to manipulate the timing advance. No, not manipulate, but I can manipulate the moment when the timing light flashes. So let's say it's idling. It is set statically at 9 degrees top dead center. So if you just hook up the timing light, it will always flash whenever the ignition happens. And you will ultimately see your S mark in your timing window on your engine case. But then with my timing light, I can now manipulate the time when that flash happens. So I can verify even if a timing mark that's supposed to be 9 degrees is 9 degrees. So I can now punch in -9 degrees, and then it will flash on the OT mark, for example. And with that method, I was able to identify where 6 degrees are supposed to be, and manipulated this around. So once this is torqued down, I think it gets 24 Newton meters, so it's not really super much. You can still lock the crankshaft with the flywheel, and then I was able to, ease it forward or backwards to adjust the timing. Now my motorcycle here is set at 6 degrees before top dead center for idle timing, And then I have selected a timing curve. Here, let me take you over to the other side. So here one more time real quick. This is the general location where the voltage regulator of your R90 or other Airhead is usually mounted. And I use the original mounting points to also mount the module for the Silent Hektik ignition. Here's a little piece of sheet metal that protects it from rain, water, whatever. And this thing has two adjusters. One is for the ref limiter, and the other one is for the timing curve. And they have a bunch of different ones available. I think I'm running 32 degrees advance right now. And then you can select between a shallow and a steep advance. The mechanical advance unit that came off of this bike, that's usually mounted right down here on the end of the camshaft, right there. I took that off. Points are still in place, as you can see. That actually has a relatively steep advance curve. If I'm not completely mistaken, the model that I was running already reaches full advance at 3,200 RPM. This one here is a little over 4,000 RPM that it reaches its full advance. But the onset of that curve, yeah, you can have shallow or steep. And I'm running a 32 degree total advance shallow, I want to say. I could look that up by setting off those little switches here. But yeah, so this is where it's mounted. Pretty much the voltage regulator and this unit here are sharing the mounting location on the frame. They kind of tell you to mount it in a way that the connectors are pointing backwards away from rain and wind and water, but I just couldn't make that work here with a tank over it. It would always touch the tank, and then I ended up mounting it that way and just, you know, put a little sheet metal protector in front of it and put the electric grease around the connector so water cannot get in there. And so far I'm pretty happy how it runs. The one huge advantage of using a crankshaft mounting trigger for your timing is that the slop in the timing chain between the camshaft and the crankshaft, you know, usually your points are run by the camshaft, and if you have some sort of slop in your timing chain, you will have shadow timing marks. So you will get kind of like a, you know, let's say we're looking at the OT mark. Let's say this would be the S mark here. It would always be showing up double, kind of like as a shadow. And that the difference between, or the distance between those two S marks is pretty much the slop in your timing chain. So once you put the trigger onto the crankshaft, all that is pretty much taken out of the equation, and you get a little bit more solid ignition timing. And then the other cool thing about this particular model here is the EME version of this crankshaft triggered ignition. You have to manipulate your engine cover from the inside, because the pickup wheel is bigger and something grinds on the inside of your engine cover here. This one you mount, it has enough space, you don't have to do anything. And then another advantage in general of a crankshaft mounted ignition system is that you can leave your points in place. You take your advance unit off, put it in a little Ziploc bag, put it under your seat into your toolbox there. And if this ever craps out on you and doesn't want to work anymore, you literally have to only open this up once, put your advance unit back in there. You don't have to change the settings of your points. The points here, let me turn on some light for you. The points are currently absolutely not touching anything. So the camshaft is running, nothing is touching the camshaft, nothing is moving. The points are closed. They're not connected to electricity. They're just in there how you left them. So if this was a working ignition, you pull the advance unit out, it sits there until it's needed again. And then up here, I really only have to pull 2 cables off. The positive and the negative coming from the Silent Hektik unit, and then put the old cables back on there. The one that goes down to the points, and the one is a positive. And they are both lingering here somewhere. Maybe I should make a little bit more effort in, here's one, that one, and the other one is down there. I even marked it. So on this side of the road, you can take your front engine cover off, put your advance unit back on, take your tank off, put 2 cables, pull 2 off, put 2 back on the ignition coils, and you're back in business with your points. So that's the great advantage of having a crank-driven ignition system. Yeah, so that's the install part with a little bit of theory. I know this is getting really long. We'll see how short I can edit this video, but I just didn't want to shortchange you guys. So piston stop in this angle, not a good idea. So just go with the timing marks that you already have. If this is a running motorcycle and you have proper indications of your timing marks on the flywheel, just use those to install a ignition system. So here in this case, Silent Hektik from Germany. They claim to be the inventors of this whole thing. So whoever else is making a crankshaft driven pickup system, they say that they are just copying them. Oh, by the way, on this Boxer engine, you will always have a waste spark system. So that means both spark plugs are always firing at the same time. As I mentioned, on a Boxer engine, the pistons are always moving in the same direction. So if this piston moves outwards, the other piston moves outwards as well. On one side, it's the exhaust stroke, on one is the compression stroke. So this will fire and actually do the bang and the power producing, and over there, the spark plug will just fire and nothing will happen. But this will always stay the same way. So with this, you will still have a trigger of both spark plugs. So it's always waste sparking on one side. The other side is doing the work. The other one is a waste spark. So that is not really, cannot be built any other way. So since you only get 360-degree turn out of this. Therefore, both spark plugs always have to fire at the same time. Yeah, and the only way that you couldn't have a waste spark system would be if it is crankshaft driven, but I just explained why you would want to go away from that. So crankshaft driven is definitely the way to go. Hall sensor pickup, I guess EME's version uses a light sensor, kind of like a light bar trigger, but similar setup. And the electronic box here looks a little different, right? It's fully potted in epoxy, only has 2 connectors. One is just the connector coming from the trigger, and one is for power supply and going to the ignition coils. It's actually pretty simple. You just have to make some sort of arrangements. Here, let me turn on light. Here's a little trigger wire coming out of the grommet. To run it right where you have all the other wires that go to your diode board and whatnot. Route that right through. I had a lot of extra. That's why it's still lingering here. Not too happy about that, but I just didn't want to go through the trouble of repinning this connector. So all this hangs right there. And yeah, that's pretty much it. The other sections of the video, like I said, I already filmed one quite a while ago. There are gonna be a couple follow-up videos. There is a video floating around that deals with some full throttle run stuttering that my bike has. The Airhead list, it's an email list. They help me diagnose and made suggestions, and then I tried all those suggestions, and this will turn into another video. Thanks for your endurance and thanks for watching, guys. Take care.